for 1D lattice as well as 1D monatomic lattice and 1D diatomic lattice. Okay, and we have seen that for 1D diatomic lattice we have only one dispersion curve, and 1D monatomic lattice we have one dispersion curve, and 1D diatomic lattice we have two dispersion curve. Okay, so in general what happens? Okay, so in general if you have if you have a f degree of freedom, okay, if you have a f, that is a degree of freedom. I'm writing generalization, no? Generalization. So you have a f degree of freedom. That means it can be 1D, 2D, 3D, 4D, ND, for whatever dimensions are there. And then you have a f number of p number of atoms per lattice point. Okay, p is the number of atom. Okay, per lattice point. Okay. Okay, or number of atom in unit cell. Okay, number of atom or number of atom in unit cell, primitive unit cell you say, and then in that case total number of dispersion curve will be fp. Okay, so dispersion curve, okay, will be fp. For example, we have a f equal to 1 and atom is equal to 1, so we have one dispersion curve. We have f equal to 1d, atoms are 2, so we have two dispersion curve. Okay, similarly in other dimensions you can calculate. Okay, so out of this fp, okay,
Sir,
f will be the
that one.
yeah explain. Okay, so your total will be fp curve. Out of fp curve, f curve will be acoustic curve. F will be your acoustic branch. Okay, F will be acoustic curve or acoustic branches. Okay, or curve and remaining fp minus f will be your optical branches or optical thing. Okay, so let us discuss by example. Okay, so suppose I have, okay, f equal to 1. Okay, I have a f equal to 1.
Sir,
your
degree of freedom means?
Degree of freedom is like in 1D degree of freedom is 1, 2D degree of freedom is 2, 3D degree of freedom is 3. So dimension 1D, 2D, 3D, 4D, that is degree of freedom here, meaning. Okay, if atom in 1D, okay, 2D, 3D. Okay, so what will be those things? Okay, so for example, I have a f equal to 1. Okay, I have a monoatomic lattice. Okay, monoatomic 1D lattice. Okay,
so p is equal to 1.
so we have p is equal to 1 and f is equal to 1. Okay, p is equal to f is equal to 1 and p is equal to 1. So we have total only one branch, total fp will be 1 only. Okay, so we have 1 only, so we have only one branch. Yesterday we have seen omega versus k if graph we see. Okay, then what we are getting? We are getting only this curve. Okay, and that is called what? That is longitudinal acoustic branch. Okay, longitudinal acoustic branch. So this is for what? This is for f equal to 1 and p equals to 1. Okay, now suppose we have f equal to 2. Okay, and f equal to 1 and p equals to 2. Okay, so in that case total branches will be Okay, FP equal to total branches. Total branches will be 1, and total branches will be 2. Okay, so out of 1 will be your longitudinal acoustic, the same branch. Okay, and other will be your what? Other will be your this way. Okay, this is what? This is what? Longitudinal optical branch. Okay, so you will be having acoustic 1, and because FP equal to 2 and 2 minus F. Okay, FP minus F. Okay, FP minus F, that means 2 minus 1, remaining will be your optical. Okay, now let us give me one more example. If I have F equal to now 2 and P equals to 1, and now how many branches will be there total?
2.
And there will 2 branches, and 2p minus 2, out of these 2 branches, F will be acoustic, remaining 2p minus 2, 0 will be longitudinal. So you will have 2 branches now. Okay, one will be transverse acoustic, one will be longitudinal acoustic if F equal to 2. Okay, similarly now if F equal to, so acoustic will be how many? Acoustic will be 2 and optical will be 0. Optical 0. Okay, now F equal to 2.
Sir, please explain this one once again.
You have total branches is FP, correct? Okay,
Yes,
FP
sir.
total branches will be how many? 2.
2.
Okay, and FP minus F is optical branches. So 2 minus 2 is that means 0. Optical
0.
2 0. That means all the branches are acoustic. Okay.
Okay.
No, let's see one more time more. Okay, now F equal to 2, P equal to 2. Total how many? Total will be 4. Okay, so out of 4, 2 will be what? Acoustic. 2 will be acoustic. Which one? Longitudinal acoustic and transverse acoustic. And 2 minus 2, again 2 will be longitudinal. So this is one longitudinal acoustic optical is there. Now transfer optical. So optical will be also 2, and that will be also 2. Are you getting?
Yes, sir.
Okay, now let me write for 3. Say F equal to 3. Now P can be 1 2 3 4 5, anything it can be. Okay, now F equal to 3. Okay, so F equal to 3 and P equals to 1. Now total will be how many? If FP equal to total will be 3, and all 3 will be acoustic. All 3 will be acoustic. They say this is transfer acoustic 1, this is transfer acoustic 2. And if I take F equal to 3, P equal to 2, our total will be 6. Out of 3 will be acoustic, remaining 3 will be optical. Okay, so you can write here. Okay, so say this is transfer acoustic 1, this is transfer acoustic 2, this is transfer acoustic, and this is longitudinal optical. Okay, similarly here you can plot one more. So this is 1 and this is transfer acoustic 2. Okay, so you'll be having 6. Okay, so in this way you can generalize for 1D, 2D, 3D. Okay, now based on this we have some problems from your exam. Let us see those problems. Okay, very simple problem what we have done, nothing much.
Sir,
Huh?
please.
Huh?
थोड़ा side हो दिख नहीं पीछे से
Okay,
draw करो.
okay. So let me draw it, solve some problems. Okay, so can I erase this one now? Okay, so
Sir?
suppose
in the right hand side, you have written longitudinal optical and then transverse optical, na? Transverse optical 1 and 2. This one.
Yes. If
Okay.
if they are first will be longitudinal and other will be transfer 1, 2. Okay. So like this here, top will be longitudinal optical, then below will be transfer optical 1, transfer optical 2. Okay, longitudinal will be always 1. Okay, whether is it acoustic longitudinal or optical longitudinal, longitudinal will be only 1. Remaining whatever number will come, that will become transfer 1, transfer 2, transfer 3, and acoustic 1, acoustic 2, transfer optical 2. Are you getting what I'm saying? Okay. So now the question came in GATE 2011. Okay, so they're saying, okay, for three-dimensional crystal having n primitive unit cell. Okay, so you have three-dimensional crystal. Okay, three-dimensional crystal means F is given 3, and three-dimensional crystal having n primitive unit cells. Okay, with a basis of p atom. So number of atom is p. Okay, you have a for three-dimensional crystal having and primitive unit cell with the basis of p atoms, the number of optical branches will be. Okay, so optical, you're asking optical branches. The option is given 3. Okay, B 3p, C 3p minus 3, and D option is given 3 and minus 3p.
Question फिर से repeat करिए.
So you have three-dimensional crystal and you have p atom inside this one. Okay, p atom basis. Basis matlab basis, you know what, group of atoms. 3 atoms are in one unit cell. Okay, so he asking what is, how many optical branches will be there? Optical branches, how many?
3p minus 3.
Okay, so if F is equal to 3, 3 will be your acoustic. Okay, total will be 3p. Total will be how much? 3p. Out of this will be your acoustic, and remaining 3p minus 3 will be your optical. So this is the correct answer. See. Okay.
Sir, can you explain once more?
I already explained so several times. Okay, so this is, you have F, degree of the crystal is 3D and basis of p atom. So total number of will be how many? Total number of, you tell me now, how many total branches will be there? Total branches. How many total branches will be there? Just now someone asked question, na? If you have F3 atom p atom basis, number of atoms are p, then total branches will be how many? Am I audible? Total branches 3p. Total branches will be 3p. Out of 3p, acoustic will be how much? Acoustic will be 3.
minus
And optical will be how many?
minus
Total minus 3. 3p minus 3. So you're asking how many optical branches are there? So this is this. Are you getting now? Okay. As 2-3 times I earlier also explained. Okay. Okay. So this is the one question, and let me solve one more problem. This problem came in GATE 2020. Okay. Now he asking, consider two-dimensional crystal. They given two-dimensional crystal. Okay. So degree of freedom is F. Okay. So you can either you say degree of freedom or you say crystal dimensions. Okay. If you're not understanding here in the case here, if 1D is there, the degree of freedom is 1. 2D is a degree of freedom 2. If 3D is a degree of freedom is 3. So crystal dimension. Okay. Crystal dimension F is equal to 2. Okay. Now say consider two-dimensional crystal with 3 atom in the basis. Okay, 3 atom in the basis means your P is 3. Okay, so he says the number of allowed optical branches and acoustic branches. Okay, so he asking N is your optical branches and M is your acoustic branches. Okay, So you're asking what is an NM? The option are given NM equals to 2, 4, B NM equals to 3, 3, and C NM equals to 4, 2, and D NM equals to 4, 2. Okay. So which is the correct answer?
NM is equal to 4, 2.
4, 2, sir.
Other?
2, 4, sir.
So
So 4, 2.
very good. So no, but now what he has written opposite. Okay. M
Yes,
is
sir.
M is acoustic. Okay. So 2 will be M. Okay. 2 will be M. Okay. And total is 6. So 4 will be your optical. So he's asking N. He's not asking MN. He's asking NM. Okay. So this will be 4, 2. Okay. Are you getting now?
Yes, sir.
Okay. Let us solve one more problem which came in net exam. Okay. Now this problem people have to do. I won't do. Okay. So this problem is they have given one unit cell. Okay. Okay. So they say you have barium titanium crystal. Okay. So they have given one crystal. And then so here at the corner we have this is a corner. Okay. Corner atoms. So corner atoms, okay, are barium. Then here these atoms at the face, this atom is say oxygen atoms. Okay, oxygen atoms, and the center we have one more titanium atom. Okay, this is a titanium atom, Ti4 plus. Okay, so this is barium titanate unit cell, barium titanate. Okay, very important ceramic. Okay, used in superconductor also, dielectric also. Okay, many applications are there. Solid cell also. Okay, now lot of work is going on this material. Okay, so you say barium titanate crystal is a cubic perovskite structure. So this is your perovskite structure. Perovskite structure. Okay, this is a perovskite structure. Now you're asking. So first, let me know what is the value of P here.
5.
इसका मतलब क्या है? प्रोवेस्टेक स्ट्रक्चर मतलब
इसका नाम है इस स्ट्रक्चर, जैसे अभी आपका क्यूबिक स्ट्रक्चर होता है, एफसीसी होता है. ओके, सो इस तरह के इसको स्ट्रक्चर को बोलते हैं प्रोवोस्काइट स्ट्रक्चर, जिसका यूनिट सेल ऐसा होता है ना, उसको बोलते हैं 5 यूनिट हो और इस तरह से हो. ओके, ऐसा कई तरह के स्ट्रक्चर होते हैं, तो उसको बोलते हैं प्रोवोस्काइट स्ट्रक्चर. ओके, तो नाम तो ऐसे दिया है. क्वेश्चन उसने क्या पूछा है, बेरियम टाइटेनियम क्रिस्टल इज अ क्यूबिक perovskite structure, okay, where barium ions are at vertices and oxygen ions are at the center, and face and titanium at the center of the face. Okay, at the center. Number of optical phonon modes of crystal are number of optical phonons mode. Okay, number of optical phonon mode he asking. Okay, so P is how much?
5.
5. And F is how much?
3.
3, because 3-dimensional crystal is there. Okay, a crystal is there. Crystal only 3, crystal can be 3D only. Okay, so now you're asking optical branches will be how many?
F.
Optical.
F.
So acoustic will be how many? Acoustic will be 3. Total will be how much? 15. So optical will
15.
be, so optical will be what? 12. Okay. So they are given option A, B, A option they are given 12, B they are given 15, C they are given 5, and D they are given 80. Okay. So option A should be correct. Okay. If it is asking optical. Okay. Let me check. Okay. Next question. No? So yes, 12 is the correct answer. Okay. So this was your how to write
Sir, here
the
how you have calculated P? Please explain.
P. Very good. So P is okay. You have corner atom. Okay. So contribution of corner atom will be how much in
1
unit
by
cell?
8.
1 by 8. Very
1 by
good.
8.
So we have 1 by 8. Okay, 1 by this is a 8 barium atom corner atoms. Okay, 8 corner atoms. Okay, plus okay. What is the contribution of phase atom?
Sir, half.
Very good. So half into 6 phase atom. Okay, and 1 is on the center.
Center one.
So that one that is completely inside. Should be 1. Okay. So how much become? So this become your 1. This become 3. So 1. So 1 plus 3 plus 1 equal to 5.
So we have to here calculate any n efficiency, any effect.
Yeah. Yes. N effective. The number of atoms in the B 1D 1D you have point only. Your units are only point only, na. Okay. Now 2D it will be square and two dimensional, rectangular, square, whatever you 5 types of I told you. Unit cells. Okay. Symmetry allows. Okay. 3D you will be having 3D crystal. Okay. So this is your unit cell. So P is what number of atom in unit cell.
सर
हाँ,
सर अगर इसमें इसी क्वेश्चन में ये पूछ लिया जाए कि लॉन्गिट्यूडनल ट्रांसफर्स भी बताओ कितना होगा तो फिर एक लॉन्गिट्यूडनल और बाकी ट्रांसफर्स होंगी
वेरी गुड बाकी तो एक लॉन्गिट्यूडनल कस्ट होगी और बाकी
जिससे
दो जो
12 आंसर आया हमारा सर जैसे
हाँ
तो इसमें
हाँ
अगर लॉन्गिट्यूडनल ट्रांसफर पूछ लिया तो 1 लॉन्गिट्यूडनल ऑप्टिकल एंड अदर्स आर
बाकी
ऑल ट्रांसफर्स
ऑल ट्रांसफर्स यस वेरी गुड
सर अभी जो क्वेश्चन आया था ना, मतलब लॉन्जिट्यूडिनल और ट्रांसफर दोनों में ही पॉसिबल है ना, एक्वास्ट इसमें भी और
हाँ
ऑप्टिकल में।
हाँ
वो एक एक्वास्टिक में एक ट्रांसफर और बाकी सारे
लॉन्गिट्यूडनल हमेशा एक ही होगा, लॉन्गिट्यूडनल अकॉस्टिक में भी एक होगा, ऑप्टिकल में भी एक होगा, बाकी बच्चे सब ट्रांसफर होंगे, ट्रांसफर अकॉस्टिक, ट्रांसफर ऑप्टिकल्स. ओके so this was your dispersion curve. Okay, now
Sir?
let me
Sir, you said that 1 longitudinal acoustic and 1 longitudinal transverse, na?
no, 1 longitudinal optical, longitudinal branch. Okay, and the most important branch is always longitudinal branch only. Okay, so when you take see, first of all your acoustic branches are most important when you consider your thermal conductivity, your thermal properties. Okay, right. So these longitudinal waves, they are faster compared to transfer waves. Okay, so generally whatever energy you transfer in the system, that is due to your acoustic branches only, and that also like longitudinal is most important. That will be only one. Okay.
सर कोई स्पेसिफिक रीजन है कि एक लॉन्गिट्यूडनल और 2 ट्रांसफर ही होंगी?
नहीं, कोई इसमें स्पेसिफिक रीजन नहीं है, लॉन्गिट्यूडनल तो एक ही हो सकता है ना, ट्रांसफर तो कैसे हो सकता है ना, ऐसे ऐसे हो सकता है, ऐसे ऐसे हो सकता है, ऐसे ऐसे हो सकता है, ठीक है, डायरेक्शन पे हो सकता है, लॉन्गिट्यूडनल तो एक ही होगा ना. ओके, so this was your things. Okay, now let me discuss the second point. Okay, density of states. Okay, density of states. Now most important topic we are coming. इसमें से कम 25 से 30 क्वेश्चन आ चुके हैं आपके एग्जाम्स में, गेट नेट में. ओके, सारे क्वेश्चन इसी टॉपिक से आते हैं, मतलब टॉपिक कोई भी हो सकता है लेकिन बेसिक फंडामेंटल डेंसिटी ऑफ स्टेट से होता है. ओके, वो समझ में आ रहा है तो वो आसान भी है, वो समझ में आ रहा है तो बहुत सारे क्वेश्चन आपके हो जाएंगे प्रीवियस ईयर्स के. ओके, सो डेंसिटी ऑफ स्टेट्स, और ये चीज आपको स्टैटिकल मैकेनिक्स में भी सर पढ़ाएंगे. ओके, सेम है दोनों में. ओके, सो डेंसिटी और स्टैटिकल मैकेनिक्स के भी बहुत से क्वेश्चन इसी पे आता है, डेंसिटी ऑफ स्टेट्स पे आता है. सो नाउ डेंसिटी ऑफ स्टेट्स means the number of states per unit energy. Okay, okay. Density of states means number of states per unit energy per unit volume. Okay. Now, density of states can be derived. So there are a number of ways you can approach this problem, but the final expression will come always same. Okay. So now I'm computing density of states for lattice now. Okay, for lattice. Okay. So we have already seen that periodic boundary conditions. So we have a lattice. Okay. So I'm using now periodic boundary conditions. I will tell you the difference between periodic and fixed also. Periodic boundary conditions. Okay. So we have this one. Okay. So I told you that day, suppose we have total 8 atoms. Okay. So n is equal to 0 and n is equal to 8, 1. Okay. And for periodic boundary condition, we know we are taking traveling type of solution. So if I want to write solutions, okay, the solution will be in types of ux, and ux will be what? It will be a iota kx minus omega type of solutions. Okay. Now because this is the periodic, right? So this is what? This is your function of u, what? Function of x and t. Now because this is the periodic, and the initially we have a crystal. So say a 1 2 3 4 5 6 7 8 9. Okay. Now we are making out of this length. Okay, length is equal to na. Here we have 8a. Okay, so 1 2, so a. Okay, so 1 2 3 4 5 6 7 8a. Okay, here at 8a, and generally you have L equal to Na. Okay, and in this chain your number of atoms is n plus 1, but you combine these two atoms, so there will be number of 8. So the length of this circumference is equal to Na, and the number of atoms are number of atoms are n. Number of atoms, okay, equal to n. Okay, that is nothing to do with this one. Okay, now because now this is the periodic. Okay, so the amplitude at u equals to L, okay, and u equals to 0 is same. Okay, at L equals to Na. Okay, L equal to Na at the corner the same. Okay, so if I put same here, so I can get e power iota kl minus omega t and e power minus iota omega t. Okay, this calculation we have already done. So this iota kl. Okay, now suppose I'm taking only one dimension. Okay, so so you can put it k. Okay, k, right? K. Okay, so kl equals to 1, and here you have k equals to iota 2 pi n. Okay, now is it have done one dimension. Okay, so I can write iota kx equal to iota 2 pi nx. Okay, so kx will be what? Kx will be what? Your 2 pi nx upon L. Correct. Where your n is what? Your where nx is what? Nx is 1 2 3, because 0 we are considering, because 0 and n are same. You cannot count 2 times. Okay, so I'm leaving 0. So we have u and up to n atoms. Okay, kx. This is one dimension. Okay, similarly I can also write for bi-direction also. Okay, so bi-direction I can write ky equals to 2 pi nyl. Okay, and kz equals to, I can write 2 pi nz upon L. Okay, so now I want to calculate the density of states. Okay, so let me now calculate the density of state in 3D. Okay, so we have kx, ky, kz. Okay, now this is the length of k cell. Okay, dimensions of k cells. So put the heading now, density of state in 3D. Okay, density of states, okay, in 3D. So now 3D, okay, we know this is a wave vector. Okay, so in 3D your wave vector will make a sphere. Okay, if I take a k value, okay, k space, okay, so in 3D if I draw this kx, ky and kz, okay, so they will form a sphere, k values. Okay, this k value, and k is what, kx, ky, kz, and you know the, like I told you, in one dimension, I told you these are my lattice point, and the distance between two k values is 2 pi by l. Okay, just now I told you know what is kx. Kx is what, 2 pi by l nx. Ky is what, 2 pi by l ny, and kz is what, 2 pi by l nz. Okay, so and nx is what, nx is your what, 1 2 3 4 like this. Okay, similarly ky ny equals to 1 2 3 4. Okay, plus minus, okay, plus minus, because in boundary condition you got to, there also you make plus minus. Okay, plus minus, and nz is equal to plus minus 1 plus minus 2 plus minus 3, so on. Okay, now in k space each point represent a k state. Okay, so these are a points. Okay, so so if you go, if you take k values, okay, so k are discrete. Okay, so if you plot this curve for k values, this is come this way. Okay, now each point in this space is one state, and we know what is the length of one state. What is the length of one state? 2 pi by l. Okay, so if I want to take a volume of one unit cell, one k state, that will be what? If I take area, then it will be 2 pi by l, 2 pi in x direction, 2 pi by l, 2 pi by l. If I want to take volume, that will be what? So volume of, you can write volume of unit cell, or k cell, okay, is equal to what? 2 pi by l upon q. If this point is, this is very important point. If this point is clear to you?
No, sir. Please explain once.
X and Y and Z.
So
लास्ट
last class,
टाइम बाउंड्री कंडीशंस लिखी थी उसमें n मतलब जब हम n ले रहे थे 0 फिर प्लस माइनस 1 प्लस माइनस 2 ये पीरियोडिक के लिए था, वहां से 0 से स्टार्ट किया था.
जीरो वो रिपीट हो गया ना, जीरो हटा दो उसमें से, ठीक है, क्योंकि वो तो दो हमने जो चेन बनाई थी उसमें जीरो एन तो सेम ही है ना, दो बार नहीं ले सकते उसको.
k की वैल्यू 0 टू पाई बाय a उसमें आ रहा था.
0 to pi by a.
पाई बाय a.
That is for fixed boundary condition ना. This for periodic.
हाँ सर.
Periodic we have
पाई बाय a पीरियोडिक में था.
periodic में. So if you have a one dimensional crystal, okay. Okay. So this is the positive k value and this is negative k values. Okay. And I told you the difference between two values is what? 2 pi by l.
Yes sir.
Okay. Okay. So these two states are same. These two states are same. Okay. So volume of unit cell will be 2
So,
pi
but
by
this time we are not taking 0 in the initial value of nx.
You see that only why we want, that is discrete. Okay, we are showing k states are discrete. Okay, So we are putting numbers only. Okay. So this is for, suppose this is for 1, this is 1, this is 2, 3. 0 means what? 0 means here only, origin only. Okay. So now this is the your volume. Okay. Now I want to calculate how many cells are there. How many these kind of cells are there in this volume? So how can I calculate?
हेलो सर.
हाँ बोलिए.
सर यहाँ nx and y जब अपने वॉल्यूम लिया ना तो kx into ky into kz करेंगे ना, तो nx and y and z का.
So volume of unit cell is delta kx, delta ky into delta kz. भी हर स्टेट के बीच में गैप है ना. If I try to make a volume, area here, so you have a gap in x direction also, you have a gap in y direction also. So if I take one unit cell, okay, for that one unit cell, okay, so around this one unit cells, this is the area. Length is 2 pi by L, Ls is 2 pi by L, Ly is 2 pi by L, Z is 2 pi by L. Okay, so this is the volume of one state, like your uncertainty phase space. Okay, in each phase space you have a value because of uncertainty. Okay, so suppose you have this phase space, you know how to plot a graph x into p. Okay, so you know x, and you cannot determine x and p with certainty. Okay, so each x value there will be gap of delta x. Okay, and p value, the minimum value, there will be delta p. So if I take the volume of one cell here, that will be delta x into delta p in one dimension. Okay, similarly in here, if we have 3 dimensions, okay, so 3 dimension, the length is 2 pi by L between two state. So the volume of this state will be 2 pi by L cube into 3 dimension, 2 pi by L square to 2 dimension, and 2 pi by L equal to in 1 dimension. Okay, I hope now it is clear.
I got that, but delta x जब हम निकालेंगे तब nx फैक्टर चला जा रहा है क्या?
हाँ तो चला जाएगा ना भी. निकालो डेल्टा nx. Suppose you calculate delta kx, what will be 2 pi L delta nx, and delta nx कितना है भी? डेल्टा nx कितना है 2 वैल्यू में? 1 का डिफरेंस तो है. n changing 1 2 3. Okay, delta x, if you take delta x, so gap between 2 and x value is 1 only. So your delta nx is 1 only. Okay, plus minus 1. So it's clear now. So just you have to remember, okay, the unit of k cell in 3 dimension is this one, cube, and 2 dimension it will be square, and 1 dimension it will be 2 pi by L. Okay, the dimension of unit cell is 2 pi by L. The interval between 2 k value is 2 pi by L in periodic boundary conditions. And fixed boundary condition, the same thing was what? P by L, pi by L. 2 was not there. 3 dimension pi by L cube, pi by L square, pi by L in different directions. Okay, now I have to calculate the number of states, number of k states. How many I know the volume of k state. Okay, I know the total volume. Okay, so I want number of k state. So number of k state will be total volume upon volume of k state. Now what is the total volume? Tell me.
Sir, 4/3 by k cube.
तुमने कर रखा है पहले, बाकी को other people. What is the total volume here? What is the volume of space? What is the k is what? X kx square, ky square, kz square. So what is the volume? What is the volume of this sphere?
4 by 3 pi k cube.
1 by 3.
4 by 3.
4 by 3.
4 by 3. Okay, very good. The volume of this is 4 by 3 pi k cube, and volume of k state is how much?
2 pi by L cube.
5 by
2 pi by L cube. See, if you know the volume of one cell and you know total volume, so you can know now how many states are there, isn't it? If you know total volume and you know the volume of 1k state, if 1k state you divide this one, you can know how many states are there. Okay, so this is your total nk states. Okay, and I want density of state. Okay, so first this thing should be clear. Now this is in periodic boundary condition. Now same thing if I write in fixed boundary conditions. Fixed boundary. So in fixed boundary condition, I told you k cannot be negative. Okay, k can be only positive. So if I take only positive value k, then what is the volume of the sphere? Only taking positive values.
By
I don't.
8. 1 by 8.
1 by 8. Because only this quadrant, you can assume this is sphere. Okay, let me take this ball. Okay, this is sphere. Okay, so if you take this sphere, you cut in 8 parts. Okay, so only one region will be where your nx, ny, nz is positive. Okay, other all portions you will be having negative values. So this is the only this portion, this half portion. If I cut in 8 parts, only this volume will have a k positive k values. Here if you go here, k negative. Okay, there kz negative. So only this portion will be your k positive. So in fixed boundary condition, you have to take volume as a 1 by 8, 4 by 3 pi k cube, and the volume of unit cell is how much in fixed boundary condition? What is the volume in fixed boundary condition?
Pi by L.
Pi by L. Very good. So pi by L cube. Now these both expressions are same only. See here you can, if this 8 will come out. Okay, 8 is already there. If I take 8 out, this will become pi by L cube. So whether you take fixed boundary condition or you take periodic boundary condition, number of state will be same. So that's why I told you when we are doing this 1D lattice, the number of lattice points n are same. Okay, number of modes are same. Interval may be different. Okay, in the case of periodic, we are a 2 pi by interval. Okay, but now here we have interval only pi by L. The number of lattice points there also modes will be equal to number of lattice points. There will also, and so this is only tools. They won't create any difference in physics. Okay, so here both are same thing. So either you use periodic boundary condition or this boundary condition, nothing matters. Here we are taking negative k value also. Okay, I hope I have cleared the things. Okay, now I want density of states. Okay, so density of states generally you write by dk or ga also. Okay, density of states. Density of state is number of dnk upon dk. Okay, so number of state will be dnk upon dk. That is your density of state. Number of k states per unit k interval. Okay, so if you calculate this one, so this is equal to what? L upon 2 pi cube 4 upon 3 pi k cube. Okay, so if you solve this one, what will come? L cube 8 pi cube 4 upon 3 pi k cube. Okay, pi cancel, we have pi square, so 1 cancel, you have 2 here. Okay, so you have L cube 6, L cube k cube 1 by 6. Okay, now if you differentiate this one, so what will come? L cube you can write volume, so v upon 6 into k cube, and pi square also there, pi square also there. Okay, pi square also there. Now if you differentiate this expression, you get v upon 2 pi square k square. Okay, and if you write dk, sometime in books they use gk dk also. I generally use this gk dk. Okay, this
Sir, in the dk there should be the pi square in division, na?
Pi square is there, na? Pi square is there. Okay, so you have 2 pi square Okay, k square dk. So this is your density of states in for k states. Okay, in 3D. This is the expression. So this is very important expression. So you can remember like this: gk in 3D is equal to v upon 2 pi square k square dk. So your gk in 3D is proportional to k square. Now remember one thing, here I am only taking k states. Okay, I am not involving any polarization. Like we have taken a 1D, there's a 1D lattice, one piece, 1, 2, 3. So that polarization I'm not taking now. Polarization we will take when we solve this for one-dimensional solid, two-dimensional solid, three-dimensional solids. So I am not including here polarization. Like in the case of electron can be spin up, spin down. Okay, so like here also we have polarizations of this vibration branches. Not polarization number I'm not including. So if we included polarization number, I have to multiply this thing by this polarization constant. Okay, in 1D it will be 1, 3D if one atom there will be 3 branches. Okay, so that factor still I have to multiply. I'm multiplying here. This is my, that depends. No, you are dealing with phonons, you're dealing with electrons. Okay, what is the case? So that that multiplication factor we'll see later. This expression you have to remember. Okay, this is the density of states in 3D. Yes.
dk is our capital dk is our density of state. Now that we have
capital dk, and this is differentiation.
No. So what is the difference between small gk? क्या दिखा रहा है यार?
GK is just an expression. Some book they write DK, some book like GK. Okay.
Same.
Okay.
Thing.
Same thing. I generally use this term GK DK. Okay. And most standard book they will use GK. Some book they will be DK. अब D for density आता तो सुनने में आसान लगता है. Okay, so that's why I use in the beginning D. Okay. But generally the term with symbol which is used, that is small g. Okay. Now you can calculate this for now 2D. Same what we have done. Now you know 2D, what 2D you have, what is the area, and you know what is the area volume of 2D cell. So you can same find for 2D also. Okay. So density state for 2D calculate. So density of state in 2D. It's very simple. You just have to remember the volume of unit cell is 2 pi by L cube in 3D, 2 pi by L square in 2D, 2 pi by L in 1D. That's it. Nothing. It's the density state is very simple. Okay. And now if you want density state in 2D, okay. So 2D, now we will have what? Circle. K values will make a circle. So you have Kx, you have Ky. Okay, so you have now this circle. Okay, circle. Now what is this? Okay. Now it will be clear more. Okay, what I'm saying, negative, positive values. Now the volume of K state, volume of or area of K state. Now, okay, instead of volume, what will be area of K state will be simply 2 pi by L square in the case of periodic boundary conditions. Okay, so number of K states. Number of K states will be how much? Area is how much?
Pi k square.
Pi k square. Very good. And the volume of K state is, area of K state is 2 pi by L square. This I'm doing in periodic boundary condition. if I take fixed boundary condition, then what is the volume?
1/4.
Very good, because now I'll take only k positive values. So the area, the volume will be 1 k square, and the area will be upon pi upon L square. But both expressions are same. Okay, so if you take 2 out, this becomes same. So there's nothing change. Okay, periodic boundary condition, just it is more close to explain something in reality, because we have traveling waves, we don't have standing waves. When we have discussed this periodic fixed boundary condition, that is for standing waves. Okay, like you do in quantum mechanics when you solve particle box. That time you solve this for this thing for standing waves. Okay, that same thing you can be solved for periodic condition also. So now number of k states. Okay, so number of k state, this is your nk. Okay, so your nk is equal to L upon 4 pi square. Okay, pi k square, pi cancel. So you have L upon 4 pi k square, isn't it? Am I doing any mistake? No. Now just differentiate. So if you differentiate, okay, so then dnk upon dk. Okay, what you get? L upon 2 pi.
There should be L square.
Huh?
So there should be
L square. Very good. L square. Okay, so this is your now dnk. So if I write gk in 2d, gk dk will be, okay, L square, you can write area 2 pi k. Okay, so this will be your a upon 2 pi k dk. Okay, so your gk 2d is proportional to k. Now I am not writing this in terms of energy. Okay, when we can write this expression in terms of energy also. That will do when we do for electrons. Okay, now I'm just doing for lattice. So this expression you have to remember. Okay, now similarly you calculate for 1d. now मैं 2d को यहाँ पे लिख के रख देता हूँ, gk 2d dk a upon 2 pi k dk. Okay, this for 2d and 3d में क्या था? gk, हाँ, gk 3d dk was v upon 2 pi square k square dk. ये मैं बार बार यूज करूंगा, इसलिए इसको याद कर लेना तुम लोग, साइड में लिख के लो, जब भी पूछूंगा बताना, ठीक है, क्योंकि मुझे याद नहीं रहता है. And then now for 1d, now do it for 1d. Okay, now if I do it for 1d, okay, so 1d I have a chain. Okay, 1d I have a chain. Okay, and the gap between two, we have k here minus k here. Okay, so this is 0. Okay, now these two states are same. Okay, plus k minus k. Okay, so now if I write the length, okay, so length will be now, you want states. Okay, total number of states, so the length will be now 2k. If I want number of states k, length will be now 2k, and the gap is 2 pi by L. Okay, and the length is your 2 pi by L. Now similarly, this is for periodic. If I do for fixed boundary condition, so again if I take nk, so my length will be only positive value, positive k range. Okay, how many k can be anything, na? How much k is there, and this is unit cell, so we know how many states are there. अगर ये k यहाँ तक है तो इसमें 2 स्टेट आ जाएगी. What is k means? K means range. So k is range. So this will be pi by L for fixed. So both come same. Okay. So this will come your what? Nk equals to Lk upon pi and Gk in 1d dk. Okay, that is differentiation of this one. Okay, this will be L upon pi dk, and the same thing we have done when we were doing initially. We are doing okay. So density of state will come same whether I take periodic boundary condition or fixed boundary condition. In the class when I started, I written 2 somewhere. Okay, you just correct that one. Interval is difference. Okay, but density of state finally comes same. Okay, some books they write this is wrong manner, but not wrong manner. They understand this different way. They do here L upon 2 pi, then they do adjustment later. For 2 factor, they do adjustments. Okay, better
Sir.
what I'm saying, that is best way to remember. This all should come same. Yes, boliye.
Sir, you said that in the earlier means del k equals to 2 pi by L, that you have written for one dimension, that you have to correct, no?
Oh, that you have to correct for periodic boundary condition. Okay, density of state that you don't do there. Density of state we are doing here. So this what I'm doing here. This is correct. Density of states. Density of state correct.
Sir,
One.
right side what you have written is for fixed boundary.
So fixed boundaries.
Left side is for
Periodic boundary condition. Periodic
or
boundary
and you
condition.
want to say that both are coming same.
Same, both are coming same, na? If you do now
Yes.
same thing, same NK, same will come. Okay.
Okay, sir.
So you can write note yes.
Please tell now where you have to make a change in notes.
That expression of density is stated in periodic boundary condition. Okay. So this is your now L upon pi. Oh, that one are a single book that we are doing that way, but आगे फिर वो change कर देता है उसको. ठीक है, L upon pi dk. So I always use this same method. Okay. So in this way, there will be no issue when solving any question for exam. Okay. The clarity will be very. You can see everything very clearly. Okay. Vision will be good. So if you understand this way. Okay. So this formula, all formula you have to remember. Okay. So let me solve some problem now of density of states, especially what I gave in test. Okay. So how much time is there? Okay, so we'll do some 1 or 2 problems. Okay, I'm not giving gap, I'll finish early. Okay, or you want, you can just go and drink and water and come in 2 minutes. Okay, I'm also coming. Okay, so 2 minutes break. Okay, so we are back. Now I gave one problem in test. Okay, so what they are given, so where I told you that for a monoatomic lattice, what we have derived in class, that Vm sine k by 2 for 1D, this for 1D. Okay, I told you calculate the density of state function. Okay, calculate density of states. Okay, g omega d omega. Okay, so just now we have calculated for 1D. For 1D we have calculated what? Gk dk is equal to what? 1D.
L by
L
pi
by
by
pi,
sir.
DK.
This one, okay. But now this is he asking in terms of frequency only. There's a difference only. He's asking in terms of frequency only. Okay. So if I want to write g omega d omega, so I have to write this is as a d omega, but we cannot write d omega here. Okay, so we have to divide dk. We have dk upon d omega. Okay, so this is upon L upon pi d omega, and this become d omega upon dk. Okay, so L upon pi d omega, and this is group velocity. Okay, just differentiate this equation and put value here, you'll get the density of states. Okay, so if I differentiate this one, okay, Vg, so Vg d omega upon dk, okay, that will be what? Vm sine, it will be cos k by 2. Okay, and if you do again k, so you got a by 2 again. Okay, a by 2 again. So now I want g omega. Okay, this is my g omega d omega. Okay, that is equal to what? L upon pi d omega. Okay, and upon Vg, so Vg is what? Vm a by 2, so 2 will come there, so Vm a by 2. Okay, and cos k a. Okay, so now this become 2L upon pi. Okay, d omega Vm
cos के a by 2 है, वो एंगल है ना, ऐसे हम सेपरेट के
क्या?
cos के a by 2 है ना, एंगल को cos में से 2 by है.
हाँ, तो k को डिफरेंशिएट कर तो a by 2 नहीं बचेगा क्या? cos sin को क्या तो cos
नहीं
बचा.
सर, आपने नीचे नीचे लिखा हुआ है dw by, वहां पे k a लिखा हुआ है आपने, 2 भी आएगा सर नीचे.
हाँ, 2
d
ये
omega d omega equals to L by pi d omega by something cos
something.
k by t.
cos के mod
Just
के
below.
हाँ
cos
हाँ
k by
हाँ,
2.
ओके 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 ओके, cos k by 2, cos k by 2. Okay, so now you can write this cos k is equal to under root 1 minus sin square k by 2. Okay, now just, and sin k value you can put from here. Okay, so sin k by 2 will be equal to what? Omega upon omega m. Okay, so this will be 2L upon pi d omega. Okay, Vm a is become 1 minus Vm square, so this become Vm square minus V square. Okay, correct. So and Vm will come out, so Vm will cancel, so I will having 2L upon pi d omega. Okay, Vm square minus V square. Okay, so this was the solution, option g omega d omega. Okay,
Sir, there should be a term in the denominator.
हाँ, a also आएगा, a also
नीचे
आएगा,
नीचे
a आएगा ना, ठीक है. अरे ये सब छोटा मिस्टेक, इसको बोलते हैं पेन स्लिप, वो तुम कर लिया करो अपना यार, मेरा फोकस पॉइंट फिजिक्स पे रहता है। ओके, सो दिस इज thing. Okay, density of state for monoatomic lattice. Now we'll solve some exam problems now. Okay, on lattice. अगर मिटा रहा हूं तो मना कर दिया करो किसको लिखना है तो, ठीक है, ऐसा नहीं बैठे रहो लिखो भी नहीं। Okay, so now we have some problem in NET exam. Okay, yes, on dispersion relation. The dispersion relation for optical phonons with cubic crystal is given. We are given this dispersion relation, omega k, okay, omega naught minus a k square, okay, where omega naught and a are positive. Okay, omega naught and a both are positive. Okay, positive constant. The contribution of density of state due to these phonon with frequency just below omega is proportional. Okay, so you're asking calculate the density of state. Calculate density of states.
The contribution of,
You're asking the contribution to the density of state due to these phonons with frequency just below omega naught is proportional to. Okay, so you're asking what is,
So is this 1D, 2D or 3D?
and you assume in 1D only because they did not give anything. No? You assume in 1D only. Let me check. Okay, optical phonon is cubic crystal है ना, so 3D. Okay, the dispersion relation for optical phonon in a cubic crystal, so this is 3D. Calculate density of state. I'm giving options. So you say density of state is proportional to, only they are asking proportionality constant. Okay, omega naught minus omega half p omega naught minus omega power 3/2 c omega naught minus omega square, and d is omega naught minus omega. Okay, solve.
Sir, option A, omega root minus omega का root.
वो तो करके बताओ, बाकी क्यों कर रहे हो तो करने दो। कैसे किया 3D में, कैसे किया, जस्ट लेट मी चेक, आंसर चेक करने दो मुझे भी। हाँ सही है, वेरी गुड। सो just use the formula for 3D. Okay, so gk dk. Okay, what is 3D formula? P upon 2 pi square k square dk. This is constant. We have to show the proportionality. So now you want k square, you want to replace this in g omega. Okay, d omega. Simply just you have to replace k square. Okay, so if you replace k square, what you get? V upon 2 pi square. Okay, so what I can write now, just check it.
k की जगह pi by omega,
Sir, K की जगह omega root minus omega का root लिख देंगे.
K की जगह क्या जाएगा? ओमेगा माइनस ओमेगा नॉट का हाफ.
Omega naught minus omega.
ओमेगा नॉट माइनस ओमेगा. ओमेगा नॉट माइनस ओमेगा. ओके, वेरी गुड. And divide by a, na? Divide by a also. Omega naught by omega. Okay, so this will come here, omega and omega, and this a will come here. Okay, so this is asking what is the proportional constant. The proportional is omega naught minus omega ka power half. Okay, so first option is correct. ऐसे ही बस फास्ट क्वेश्चन, डेंसिटी के सारे क्वेश्चन ऐसे ही फास्ट हो जाएंगे जितने भी हैं, चाहे इसके हो, चाहे बैंड थ्योरी से रिलेटेड हो, चाहे किसी से भी रिलेटेड हो. हाँ बोलिए.
decay term is also there, na? So we have to take consideration that also.
So decay you can remove here, na? Just you can just want this one, na? Okay.
क्वेश्चन में तो k स्क्वायर है ना, फिर d नहीं आना चाहिए.
k स्क्वायर है ना?
हाँ तो k
तो के स्क्वायर को हमने रिप्लेस कर दिया ना इससे।
हाँ तो फिर से अंडर रूट कैसे आ गया वहाँ पे? ओमेगा
यस सर।
ऑप्शन डी आएगा सर।
ऑप्शन डी आएगा क्या?
यस
सर
सर।
ऑप्शन डी करेगा, अंडर रूट नहीं होगा सर।
अंडर रूट नहीं होगा,
हाँ,
अच्छा
square
हाँ तो ठीक है, फिर डी होगा ऑप्शन। इन्होंने कैसे कर दिया डी, इसमें कैसे कर दिया?
सर बट सर डी के को जब डी
हाँ
ओमेगा से
हाँ,
रिप्लेस
ओके ओके
करेंगे
ओके ओके
तो
ओके 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 ओके, करेक्ट करेक्ट, यू आर करेक्ट करेक्ट। डीके करना पड़ेगा, सॉरी करना पड़ेगा, जीके डीके ओके करना पड़ेगा, जीके डीके ना, जीके को इसको रिप्लेस करो डीडब्ल्यू से।
रिप्लेस करके आ जाएगा सर।
हाँ रिप्लेस करना पड़ेगा, सॉरी।
मतलब डेरिवेटिव लेना पड़ेगा ना।
ओके सो के स्क्वायर, so you have k square equals to, so पहले d ओमेगा कर देते ना, d ओमेगा equals to minus 2ak, okay, d omega by dk, so this is dk, okay okay. Now if I write v upon 2 pi square, okay, k square, so k square will be your omega minus omega naught, okay, and k is here, k v upon pi square, k square is your omega naught minus upon a, okay, very is correct. And now I have to write dk, dk will be minus d omega upon 2a, okay, and k also, so बेटर ये k स्क्वायर रहने दो, यहाँ पे काट दो, k स्क्वायर आगे फिर काट लो, ठीक है, तो k स्क्वायर से k कट जाएगा, okay, so now v upon 2 pi square, okay, and some proportional, and here will be k, so k will be your under root omega naught minus omega, okay, अब सही, okay, ठीक, कर लोगे ना इसको पूरा, मैं करूँगी, कर लोगे ना इसको?
यस सर कर लूंगा।
यस सर।
okay, so
फाइनल आंसर क्या आ रहा है?
ए ऑप्शन प्रोपोर्शनल
रूट में आ रहा है।
हाँ रूट में आ रहा है, के कैन, हाँ बोलिए अब।
डी ओमेगा वाला पार्ट कैसे क्या था वो एक बार बताएंगे प्लीज?
अच्छा भाई, ओमेगा और के में रिलेशन दे रखा है ना, ओमेगा में क्या रिलेशन दे रखा है, ये क्या दे रखा है, ओमेगा नॉट माइनस क्या दे रखा है बताओ?
ए के स्क्वायर।
माइनस ए के स्क्वायर।
हाँ तो डी ओमेगा चाहिए, डी ओमेगा बाय डी के करो तो क्या आएगा, ये तो कांस्टेंट है तो 2a के नहीं आएगा, सो यहाँ से तो डी ओमेगा इक्वल्स टू व्हाट, माइनस 2a के डी के, ओके, नाउ इफ यू वांट डी के दैट विल बी इक्वल टू डी ओमेगा अपॉन माइनस 2a के, क्लियर?
के किससे रिप्लेस किया बाद में तुमने? ये के किससे रिप्लेस किया बाद में, ये जो डिनोमिनेटर में डीके का के आ जाता है
ये फिर के यहाँ से रिप्लेस कर देंगे वापस, फिर डी ओमेगा क्या, डी ओमेगा माइनस 2a के, अब के यहाँ से रिप्लेस कर देंगे, ओमेगा नॉट माइनस,
सब्स्टिट्यूट किया है ना रूट से।
हाँ तो फाइनली आंसर हमको ओमेगा 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 सारे ओमेगा में लाने हैं ना,
ओके
ठीक है भाई, what I've written these three equations k states, okay, these are the master equations, समझ रहे हो master equation क्या है? Now if once you are know k, so just now we have given relation omega and k, so you can convert in omega. If you are given relation energy and k, similar way you can convert that k state into E energy states. Are you getting my point what I'm saying? What three equations I am writing, you write near to three equations, these are master equations, तो हमेशा याद रखेगा, लिख दो वहाँ पर, these are master equations, okay, so these equations are given. Now the relation between omega and k can be anything, k square, k cube. Similarly energy and k relation can be anything, E proportional to k, E proportional to k square, k cube, different type of particles, okay, different type of systems, but those three gk 1d 2d that they will be always same, okay, that's why they are master equations, okay, so उसको note कर लो, बहुत important है उसको. So let us solve some more problem, okay, how much time is there, okay, so we'll do one more problem. और previous का question तुम भी करो, सारे थोड़ी क्लास में हो पाएंगे. The dispersion relation is net, this exam came net, the dispersion relation of phonon in solid is given by, okay, a dispersion relation is given. omega cube 3 minus cos a cos k by a minus cos okay kz a. Okay, so this is you're asking the velocity of phonon, for large wavelength. Okay, calculate velocity of phonon for large wavelength. What do you mean by large wavelength?
K will be very small, so
can-
we can extend the cos kxa.
Yes, you can put k tends to 0. That means the cos x a can be replaced by what? 1 minus
Kx square
kx square by
by
2.
2.
Yes, karo solve karo, and then
Sir,
you have to
would it be omega not a by root 2?
omega
Not
yes
a by root 2.
yes omega a by root 2. Yes, check करने का आंसर मुझे ऑप्शन दे रखा है. I am writing options here. Okay, then you have to tell me what is the option. Okay, everyone. So a is given omega naught a by root 3, b omega a. Okay, c is your root 3 omega a root a by root 2. So calculate the omega k relation in low frequency region and then just differentiate, or you calculate phase velocity or group velocity, both are same. When you calculate, you should get answer. Tell me what is the answer. बाकी लोग क्या आ रहा है?
Sir, option D.
बाकी लोगों को भी करने दो. किसका नहीं आ रहा है वो बताओ मुझे. जिसका आ रहा है वो तो ठीक है. और प्रीवियस के गेट के और नेट के क्वेश्चन करना शुरू करो. इसका टेस्ट भी मैं जल्दी भेजूंगा मैं. ऑप्शन क्या दे रखा है इसका? डी दे रखा है. ओके, सबका आ रहा है कि नहीं आ रहा है? ऑल आर गेटिंग?
Yes, sir.
Okay, so I'm not doing, if all are getting, I'm not doing here. If you can see, if you put the values, this 3 cancel. Okay, then you get only k square by a square, and then you can differentiate. Okay, k by root 2. If you find omega, मैं कर ही देता हूँ ना उसको. बाद में कई बच्चे तो कर भी नहीं रहे होंगे, बैठ के ऐसे बैठे होंगे. Omega square k. Okay, if you put this approximation, you get what? You'll get k square a square. So this implies omega k is equal to omega k a by 2 by root 2. Okay, so if you put d omega by dk, there will be omega a upon root 2. Okay, so let me solve one last problem, which I'm not going to solve, which we have already done in the class. You just to tell me the answer. What is the answer? Okay, so they given one dimensional lattice of diatomic lattice. Okay, so this is they given. Say this mass is m1, other mass is m2, then mass is okay m1, and then mass is m2. They are in chain. Okay, and they say the dispersion relations are given by this. Instead of k, they are writing q. Okay, k m1 plus m2, what we have derived. Okay, that is 1 minus 4 m1 m2 m1 plus m2 का square sin square qa by 2. Okay, the dispersion relation is given. Okay, So you're asking what is the velocity of sound? What is the velocity of sound? Okay, and they have given the options. They're asking what is the velocity of sound? Options they have given k m1 plus m. ऑप्शन क्यों लिखूं मैं, तुम बताओ क्या ये वेलोसिटी साउंड मैंने करा दिया था वैसे भी. व्हाट इज द वेलोसिटी ऑफ साउंड?
Sir, is there any limit given on the Q value?
Not given, but velocity of sound always calculated where k tends to 0. I told several times in the
Right.
class.
Sir,
Okay,
it's K A square by 2 M1 plus M2 root.
omega value, not omega square. Omega equals to, I have solved in the class na. What is value?
K into root under
K into root under
beta A square
beta
A square
a square
divided by 2
2
M1 plus M2.
m1 plus m2. Okay, so here beta, instead of beta we have k, na.
Yes, sir.
K, the k square 2, and outside also k is there.
Yes, sir. But when we calculate the velocity, then K will be gone.
Okay, so I'm asking velocity, no? So this is velocity. Okay, so k under root k square a square upon 2 m1 m2. So under root k a, option B is given. Okay, let me check that one. Answers question number 5. Question number 5. B is correct answer. Okay, so this is given as option B. Okay, so this is correct answer.
So there was an homework for K tend to pi by A.
बताओ क्या करना है उसमें.
सर वहाँ पे अप्रोक्सीमेशन सही नहीं था मेरा, सर एक बार बता दीजिएगा.
वो एक्चुअली मैंने होमवर्क दिया है, मैंने भी इसको कभी करा नहीं है, बट वो आएगा आंसर वही जो k इक्वल टू पाई पे आएगा. अगर अप्रोक्सीमेशन नहीं लग रहा है तो क्या करोगे, k इक्वल टू पाई बाई a लिख दो, और क्या पाई बाई a पे क्या हो जाएगा आपका, जो साइन k स्क्वायर है वो 1 हो जाएगा, या कॉस, जो कॉस है 1 माइनस कॉस k है तो -1 हो जाएगा.
यस सर.
सो प्लस हो जाएगा, तो वैसे जो मैंने क्लास में कराया वैसे हो जाएगा, सॉल्व हो जाएगा. नहीं
यस यस सर.
तो फिर एक बार फिर ट्राई करो, कुछ थोड़ा अप्रोक्सीमेशन में और कुछ कर सकते हो क्या, वरना आना
सर,
तो वही, आना तो वही है.
सर लीनियर अप्रोक्सीमेशन भी आता है, वो पाई माइनस एक्स आ, वो और कॉम्प्लिकेटेड हो रहा है सर.
हाँ तो नहीं, रहने दो उसको, रहने दो. ठीक है, मुझे चेक करने दो. ओके, कहीं कहीं दे नहीं रखा है, मैंने ऐसे तुमको सोच के बोला था, जब k टेंस टू 0 निकाल रहे हैं तो k टेंस टू पाई बाई पे भी निकलना चाहिए, और वो आना वही चाहिए जो हमारा बाउंड्री पे है. ठीक है, चलो आई विल ट्राई इट. सो आई एम स्टॉपिंग हियर. ओके, एक क्वेश्चन और कराना था मुझे, टाइम है क्या अभी? ओके, लेट इट, टुमारो करेंगे उसको, कल करेंगे. सो आई एम स्टॉपिंग हियर. कोई डाउट है क्या आज की क्लास का? ओके, सो आई एम एंडिंग क्लास हियर. थैंक यू.
सर
थैंक यू सर.
सर सैटरडे को जो आप डार्क क्लियर करेंगे वो क्रिस्टल से लेके अब तक का या इसी चैप्टर का करेंगे?
नहीं, इसी चैप्टर का अभी जो पढ़ाया है. क्रिस्टल का जिसका हो वो मुझे भेज दो अकेला, जिसका एक डाउट हो मुझे, जो भी डाउट मुझे व्हाट्सएप भेज दो. ठीक है, फिर मैं
ओके
वो टाइम मैं मैनेज कर लूंगा ना, कितना टाइम लगेगा. बहुत से डाउट होंगे, ज्यादा क्लास चाहिए, कम ही डाउट होंगे तो 15 मिनट सबका कर लूंगा मैं. ओके, so you send your doubts either me or either to Satish on WhatsApp. Okay.
सर हमने जो किया ना, इसके पहले जो क्वेश्चन था जी ओमेगा डी ओमेगा, उसमें से हमने डीके का वैल्यू सब्स्टिट्यूट किया ना, उसमें सर कैसा सब्स्टिट्यूट वो समझ में नहीं आ रहा है. मतलब आपने
वो रिलेशन तो जो रिलेशन दिया रखा है ना, जो रिलेशन दे रखा है उसी से तो मॉडिफाई करेंगे ना. जो के और ओमेगा रिलेशन रखा है उसको डिफरेंशिएट करेंगे. आप इतने सारे कैलकुलस कर रहे हो, इंटीग्रेशन डिफरेंशिएशन कर रहे हो, तो कैसे रिप्लेस करते हैं, वेरिएबल कैसे चेंज करते हैं?
डेरिवेटिव, लेकिन पहला टर्म भी हम के रिप्लेस कर देते हैं ना, मतलब के स्क्वायर जो होता है
भी, जो आपका अभी जैसे ये था हमारा, क्या था हमारा, ओमेगा इक्वल्स टू क्या था, ओमेगा नॉट ए के स्क्वायर था ना. अब हमको हमारा जीके को हमको जी ओमेगा डी ओमेगा लिखना है. ठीक है, इसको मत देखो, तो फंक्शन है. अब यहाँ वाला चेंज करना है. तो यहाँ वाला हमारे पास क्या था, बी अपॉन 2 पाई स्क्वायर था ना, के स्क्वायर डी के था. ठीक है, तो अभी क्या है, v अपॉन 2π² लिख दो। अब यहाँ से आपको इन दोनों को चेंज करना है, तो मैंने आपको डिफरेंशिएट डीके निकाल के बताया ना, डीके क्या आएगा, डी में क्या आएगा, 1 माइनस 2ak, ठीक है, डीके, ओके, सो डीके क्या आएगा, डी ओमेगा माइनस 2ak, ओके, सो के स्क्वायर डी ओमेगा माइनस 2ak, के से के कैंसिल, बच गया। अब खाली के बच गया, इस के को भी रिप्लेस करना है ना, तो ये के यहाँ से रिप्लेस हो जाएगा, ओमेगा नॉट माइनस ओमेगा बाई ए, समझ आया। 2π के भी तो बचा हुआ है, ये इस के को भी तो लिखेंगे यहाँ पे।
हाँ सर क्लियर हुआ, मुझे यहाँ कंफ्यूजन हो रहा था कि उस के का क्या है। क्लियर है सर।
ठीक, ओके, थैंक यू।